Good evening, good evening. Hello, YouTube, and welcome to Nordev this evening. I'm Alex, your host, and we are joined by Martin this evening to talk about Blazor, but I will leave him to introduce himself and tell you the subject for this evening. Just a quick note from us about upcoming events. Next month, March the 18th, if memory serves correctly, we've got a topic on emotional regulation. I did immediately reply to say, what? We don't need help with that. But Amy does insist that we may need help with emotional regulations. I don't know about you, but understanding feelings and top tips for being okay. So yeah, join us next month for that. All this month, as usual, Wednesday streams. Let's go build a bot. We're building a new bot for the Discords for Nordev, which should be quite interesting in Golang with Dom. He's obviously already served us up for January, but he's come back for February. Eager. Virtual Social Club every Friday, 5:30 till late. As the mantra goes, physically distant, not socially. Quick shout out as well. We're always looking for new speakers and topics to I wrote that and I still can't say it. Whet the appetite. DM a member of the committee. Drop us a message anywhere, really. We're all over the place and let us know. A quick shout out to the user story. Thanks for excuse me, sponsoring the Discord. Obviously the quarterly engagement prize over there. Meeseek bot, which again we're looking to replace potentially with Let's Go Build a Bot. Sponsors, we are still looking for corporate sponsors. We have several exciting conversations actually last month. So yeah, watch this space. A shout out to our patrons, a couple of new people. Thank you very much. You have literally kept the lights on for Nordev this over the winter. So thank you very, very, very much. But anyway, as we always say, I'm going to get out of the way because nobody came here to talk, listen to me. So, Martin, what's this Blazor stuff all about?
Yeah, so I'll share my screen and hopefully I'll explain what I'm going to be talking about at least. There we go. So hopefully you should now be sharing. So if anyone could just give me a shout that that's actually there. Cool, thumbs up. So we're going to be talking a little bit about building a real-time serverless application in Blazor using AWS. And to start off, I'm going to be talking about Blazor. It's not entirely about just Blazor, but it's actually about a project that I've been building over the course of about 3 years. And I've moved it over different technologies. And it's a real-time application. And the last sort of like spin of the dice was trying to convert it into a Blazor application. And so this talk's going to quickly go over like what I've done and how I've re-architected it to make it work in Blazor and some of the things that I've needed to do to make it work in Blazor. A long story short, I've made a very, very expensive real-time application into a very, very inexpensive application by using Blazor and also a few different hosted services. So it's enabled me to massively reduce the cost of this little pet project that I have, although it's completely not finished. So there's loads of work to be done. And at the end, I'll explain where the GitHub repo is if you want to contribute at all into helping me finishing it off, because it is a kind of silly idea. I am full of silly ideas. I like doing silly projects and trying to get stuff working. One of the things that I do, which is quite silly, is my introduction slide. This is my inception slide. And you'll know when I started this, these were pictures of me in front of my slide deck. So at every event I ever went to, it was a picture of me in front of my slides. Sadly, this is no longer possible because we're not actually in person. It's actually about day 350 since I last spoke publicly, not virtually. And so all of the talks that I've given recently have all been on Zoom or Blue Jeans or Chime or something else. And so these are all of the me standing in front of a slide, standing in front of a slide, standing in front of a slide. And if you do, if someone could just take a screenshot of the screen right now and then post that to me at the Beebs, then I'll have another one of these inception slides, which is me standing in front of my slides, standing in front of my slides, standing in front of my slides. If you're interested at all, you can go to the beebs.net inception and it will show you all of the different slides of me standing in front, all the way back. I think I've got nearly 70 or 60 or 70 pictures of me standing in front of slides. These are obviously me standing in front of screens for the last, well, I don't know, all the ones that I can see there are me standing in front of screens. So, I've been a web developer now for 22 years. I've been a developer since I was 16 years old. I started off as a web developer. I've worked at Microsoft, Oracle, and more recently AWS, where I've been for about 2.5 years now. So we're going to be looking at building, or what I mean when I say real-time application. Then we're going to be looking at how I built my first real-time version of this application in SignalR. Then we're going to be looking at how we could build a similar thing using serverless technology. And then finally, how we integrate that into Blazor so that we can use serverless and Blazor in combination. And the main reason why this is a good idea is, one, it will enable me to scale much more quickly. It's a lot less infrastructure for me to manage. And then lastly, it's a lot cheaper. So that's the main reason why I went this route. And I'll explain a little bit about the cost of this project as I go through. So what do I mean by real time? I mean real time, which is stuff happening in the real world, notifying your application. So we use real-time applications all the time, and we build these sorts of applications using many different types of technologies, be they notifications, push notifications, WebSockets, and lots of other technologies around that. And they enrich things like banking alerts, multiplayer games, chat applications, VR experiences, document collaboration. They're actually becoming quite common. And in fact, if you're building any kind of collaborative application nowadays, then it's likely that there's going to be some level of real-time application involved there. So whether it be developing Twitch application, or the Twitch with their chat site next to their video, having live video interactivity, all these things happening in the real world, manifesting themselves inside of our application. That's building a real-time application. Here's an example of one. When I used to go out and stay in places in places, I would maybe stay at a hotel, and I'd go to a hotel website and I'd be looking at the DoubleTree by Hilton, London, Westminster. And very quickly, a little piece of UI would pop up and say, just booked 52 properties like DoubleTree Hilton in London, Westminster, were just booked in the last 15 minutes on our site. Now, that should be a real-time notification, like someone physically, other people are booking this, and it's encouraging you to go book thing. It's like a sales incentive to try and make you go and buy this hotel room, because it's going to run out anytime soon. It's probably implemented not using WebSockets, more likely a JavaScript timer, on 15, like every 5 minutes, it will just pop up with a random number of how many people have booked. But I like to imagine that it's a real-time system, and that they've really built this UI in. Other examples, we use a document collaboration system called Quip, very similar to Google Docs or the collaboration features in Word. And it just means that one of the things I really like about Quip is that when you're on a document, it just shows you all the other people which are viewing that document. So if you've just shared it in an email, for example, and then you can see like your boss has seen it, or whoever's seen it, it's a really good sort of nice feature, all implemented using WebSockets, building real-time applications. There's a chat functionality in there. This is possibly one of my least favorite UIs in web development, which is the 3 dots, i.e. somebody's typing. Any kind of application development like WhatsApp or anything like that, that's always a real frustrating moment when someone's got the 3 dots and you're like, right, what are you going to say? Any second they're going to say something on Slack. Any second and then they stop typing what they're typing, and then they start doing it again. You see the little I'm typing, and then they stop. But every time that person's touching that keyboard, it's sending an event to a server system somewhere, and that system's being relayed in real time to your application and showing it on your screen. And that's a real-time application. Now, fundamentally, most real-time stuff on the web is built using WebSockets. Like there's other technologies that you can do this stuff. You can use server-sent events. You could use long polling, but most applications are built using WebSockets. And fundamentally, WebSockets are an agreement between an application and a server, or a client and a server, about how they're going to communicate. And the way that it works is that the application, when it goes to a website, it makes a request for the website, and then it makes a second request called a negotiation request, and it will say, look, do you support WebSockets? And the server is going to say, of course, it's 2020. It's actually 2021. I haven't updated my slides, but it will say, yeah, of course, it's 2020. Of course, I support websites. Now, the reason it has to do a check is because not all servers do support WebSockets. It's something that's required in the client and on the server. Now, almost every client platform, whether that be Android, iOS, or most web browsers nowadays, will support WebSockets in some form. But back in the day when I started doing real-time stuff in 2008, it was actually really uncommon for the server to support WebSockets, and you'd have to do all sorts of negotiation and fallbacks and that sort of thing. And once they've agreed that both sides of the party support WebSockets, they create a pipe, and then that pipe is a way that they can communicate in a duplex fashion. So you can send and you can receive messages. Now, that's different from the way that the web works ordinarily, because ordinarily it's all based upon the fact that a client makes a request from a server and the server responds to that request. The way that you would do real time back in the day was that you would send a request to the server, and the server would hold on to the request until it had new information. So it would be like an AJAX query. It would be held onto by the server, and then the server would, once it had new data, maybe a minute later or whatever, it would respond back to that request, which means that every time you want to sort of get new information, you have to have one of these requests, and then the server's having to hold on to the request. That technology is called long polling. And you'll be surprised, there's still some really high scale real-time applications built using long polling. I haven't checked in a while, but Facebook Messenger for a very long time was built on long polling. Till I think it might even still be today, but it certainly was very, very recently. The way that they must have scaled that would be really challenging, because the problem obviously is holding on to all those requests is really expensive on the server side, because you're basically pausing those requests and then responding back to them at some point later. But they must have managed to scale that somehow, and they did that. But most people are using WebSockets because they're quite lightweight on the server. There is a limit to how many you could have per server. And so when you're scaling these things, sometimes if you've got lots of communication going on, then you will need multiple servers. And that further complicates building these real-time systems. So when I joined AWS, I looked at all the sort of the console, which we call AWS console. Even that confused me when I first joined AWS, because I was from the Microsoft world. And the idea it's called a console always sort of weirded me out, because what they meant was website or portal, but they always call it the console. I thought they meant terminal or something like that, but when they refer to console, what they mean is the website where you can go and try services out. And when you go there and you look at all the services, there's just tons of stuff there. So for a .NET developer like me, it can sometimes feel really, I don't know, not scary as much, but just like there's just too much. I don't know where to start. I don't know where to get on. Now, for most applications, .NET applications, the service that you'll need to start with, especially if it's a regular sort of MVC or .NET 4 website, for example, is Elastic Beanstalk. Elastic Beanstalk is a service which allows you to basically host any kind of website or web application, and it supports .NET, and it supports lots of different versions of .NET, including .NET 5 and .NET Core as well. Now, when I came to AWS, I'd already built this little application I'm going to show you. And I built it using a technology called SignalR, which is a very old .NET technology for doing real-time stuff. And I looked and found Elastic Beanstalk, and I thought, right, I'll get it working on Elastic Beanstalk. And that's kind of what I did. So SignalR, if you're not familiar with it, it's a really popular .NET real-time framework application thing for .NET. About 5-6 years ago, they ported it for .NET Core, so you can start using it on .NET, and it's pretty much supports every version of .NET, including right up to .NET 5. It supports WebSockets, but also supports other ways of doing real-time, including server-sent events, long polling, and it can degrade based upon what the client and web app client and server capabilities are. So it's an open source framework. It's very, very useful. And when I first started using it, I was like, right, I'll take my .NET application. I will publish it to Elastic Beanstalk across 2 servers, And this is basically my architecture. I've got an elastic load balancer, and I've got the Amazon Beanstalk thing going on. And those two squares are two servers. So two servers being load balanced by an Amazon Elastic Load Balancer. So the first thing I need to do, or would do, to get my application running in AWS would be to install the AWS toolkit for Visual Studio. I live inside of Visual Studio most of the time, or certainly did when I was starting this project. And there's a really cool tool called the AWS toolkit for Visual Studio, and it makes everything very, very simple to publish. A little bit sort of IDE centered, but it means that I can just go to Visual Studio, extensions, type in AWS, and I can install the AWS toolkit for Visual Studio. There's a version for 2017, 2019. There's even versions for 2013 and 2015. You download it, it installs the V6 extension. You run that, and then it will install the V6 inside of Visual Studio. It means that you can open up any project, and this is the project that I had, AWS CYA. And I right-click on that project, and I can say publish to Elastic Beanstalk. So just under where the publish to the other cloud is regularly in Visual Studio, now we have like publish to Elastic Beanstalk. So I can say, I want to publish this to Elastic Beanstalk, and oh, I think I've got something gone wrong there. Sorry. That is not what I expected to do. Publish to Elastic Beanstalk is what I wanted to say. Anyway, doesn't matter. So when I right-click that, publish it to Elastic Beanstalk, and then it gets pushed out to Elastic Beanstalk. What actually happens under the hood is that it uses the command line interface to actually send a zip file of your project over to Elastic Beanstalk and then publish that. And what I end up with is a architecture which looks like this, which is my Elastic Load Balancer. And I chose in the, which I didn't show you there on the, it didn't quite show you on the video there for some reason, but it shows you that there was, I get options to say how many instances I want in the back end. So I could say, look, I want 5 instances, or I want 2 instances. I can auto scale those instances, but you decide how big your infrastructure is going to be. You deploy the application, it deploys them across all of those applications. The problem is with a real-time application is that when you have multiple servers and a WebSocket connection, you have this client to web server connection. And if the person reloads their browser, then it might go to another server. So you constantly have this problem of sockets not necessarily connecting to the same server that they served before. And that wreaks havoc with WebSockets. So what you have to do with most systems is on the load balancer, you have to switch on something called sticky sessions. Now, Amazon Elastic Load Balancer has this capability, and most load balancers have this ability, which basically says when you connect for the first time, they add a small cookie to the request, and then any subsequent requests that you make will send you back to the same server. So you won't be load balanced. You will only be load balanced once. You won't be load balanced on every time you revisit a site. Which means that you're going back to the same server, which is good. But it causes another problem, is that now people are connected to different servers. And sometimes when you're building applications, you want people on different servers to be able to send messages to each other. So let's just look at the application that I built. Oops, over here, hopefully. So if you've got, anyone's got a, if anybody there has got a phone, or just wants to go to the URL demo.thebeebs.net. Let me just do it myself. So I'm going to open up my camera application, and I'm going to take a picture of that. Cool. And it's going to open up the browser, and I should end up with a thing which says, please, my light's getting in the way. Please wait. I can't focus. There we go. So please wait. And then when I go over here on my version and I click next slide, which for some reason, oh, I was trying to click it with the wrong screen. The next slide, you'll see that a question's being asked over here. So it says beer or coffee. So if you go and select, if I select coffee, I make a vote for coffee over beer. And so people are voting here at the moment, and I'll let everyone vote for that. Okay, and if I go, so generally the beer's a winner in this group. And if I click on next and go tabs versus spaces, then tabs is very much the winner. We've got 11 out of 4. So you'll see that I've got this kind of simple voting mechanism, and then there's this very basic CSS3 pie chart in the middle, which moves left and right. And the only reason the pie chart works like that and not like a regular pie chart is because I'm not that great at CSS3. So as different people vote, it goes to left or right. Now, what's happening in the background there is actually quite complex. Let me see if I can get my screen over. Let me have, if I just go into more tools, developer tools. Oh no, it's come up on the wrong screen. Network. Okay, go to the network here. I might have to refresh this. You'll see somewhere there's a negotiate here. This is just in the dev tools, the network tooling. There's like a negotiate, and it makes a thing over to the voting hub to do this negotiation. This is asking whether the server supports WebSockets or not. And it does. And there'll be various other things going on in there. And then eventually it redirects it to this thing called the voting hub. And this voting hub is actually the location of the socket. And you can see all of the different, as people vote and send messages, you can see the WebSockets coming back and forth. So if I make another vote or do another vote on this screen, oh, that's weird. It's not refreshing. Never mind. You'll see, but you can see a couple which has already come in here. So someone's done it for me. Thank you very much, whoever that was. And different people asking different questions, and things will be popping up as in the WebSocket as people are voting. So it's that's a WebSocket, and it's been instantiated on the application, and all is working well. Let's go back over here. But when I'm voting now, if you join my website, the Elastic Load Balancer is going to put you on a specific application, instance. And one of the challenges we have, though, is that if some of my users are on one server and some of them are on another server, then they'll be voting, but they'll actually be the way my application works. It's just storing the votes in memory. It's not storing them in some central database or anything like that. And so you're actually only ever seeing the server that you're on. You're seeing that number update. You're not necessarily seeing all of the different people voting, and that's not good. It's not so bad when I'm working, in a team like this where there's only like a handful of people necessarily watching. But when there's maybe thousands of people at an event which are voting on things, they will definitely go across multiple servers. And so the way that we deal with that traditionally in real-time applications is we create a thing called a backplane. And a backplane, what it does is it's any sort of memory store or database. Effectively, you could have any kind of database in the background, which is just like a persistent store of all of the different messages, and it reroutes them. The idea is that we rewrite some application logic which reroutes it to all of the different servers, so that when someone votes on server A, that message gets passed over to server B as well. Now, the way that SignalR works is that you put a Redis cluster on the back end, and then you add this line of code. If it was a .NET 5 or core application, you'd write services.add SignalR.add stack exchange Redis, and then you'd point it at your Redis cluster. That's the only line that you need to add, and it will add a backplane for you, and it will handle all the application logic of routing and all that stuff. That's one of the reasons why SignalR is such a cool platform and sort of framework, is that it's a one-liner. We've got a backplane built for us, and now I know that it doesn't matter where any of my machines or people are on different machines, all my messages are going to appear to be from the same server and routed correctly. The challenge is, though, now I've got one load balancer, I've got 2 machines. Let's say a machine can take 1,000 concurrent users. This system will work for 2,000 concurrent users. Okay. Now, if I add another server on that, that'll be 3,000 concurrent users, maybe, depending on how many WebSockets a server can maintain, and that depends on the memory and the CPU and the server spec, basically. Now, let's say I want to do this for 50,000 concurrent users. Well, I've got to then scale up quite a lot of machines. And also my Redis cluster needs to be of a size which can handle that as well. All of a sudden, this gets quite expensive. It starts getting quite expensive as soon as I need more than one machine. Let's say a machine costs me, I don't know, £50 a month. And I need 5 of them. I need 10 of them. Could say 10 because it makes it easier to count. There's 500 quid, and then Elasticache from Elasticache for Redis, which is an Amazon service. Even a basic thing with replication, it's going to cost me at least, I don't know, 70, £100 a month. So it's costing me hundreds and hundreds of pounds for this. And this is a demo that I use occasionally at events. So what I end up doing is spinning it up and spinning it down. And I have a pipeline and workflow that builds it and then stops it. And that's great. But it's also, I've got to remember that pipeline. And there's always inevitably a mistake which I've made with that pipeline. It becomes a bit more complicated to set it up and set it down. And it's got to work first time because it's got to work when I'm using it on stage. So it can be expensive and a bit of a pain to work with. So I was looking for a way of doing this better. And I basically wanted a managed way of dealing with WebSockets. And then a couple of years back at reInvent, we announced a service called AWS Gateway for and WebSocket support in API Gateway. And Amazon API Gateway is a service that Amazon have, and it can do a lot of things, and there's lots of capabilities of it. But fundamentally, if you think about it as it's an endpoint that you can use to put in front of all of your different services. And lots of people use Amazon API Gateway to like front a system, and they sometimes use it to unify the API and make an API appear like it's all from one system when it's in fact multiple systems. And you can do things like building logic. You can change the way, a request comes in. Maybe if it comes in XML, you can convert it into JSON and then forward it over. And there's all sorts of things API Gateway does. But they added this capability of adding a WebSocket support to it. And I was like, cool, that sounds like something I might want to use. And what this does is it means that usually what we would have is a stateful connection between the client and the server. And what this does instead is the stateful connection is between the client and the Amazon API Gateway service. And then there's a stateless connection to our backend. And that backend could be written in anything. It could be written in a .NET in EC2. It could be, a regular web application somewhere. It can be Lambda functions. It could be anything on the backend. But the API Gateway is going to stand in front of it, and it's going to offer up a WebSocket like URL that those applications can communicate with. And when it gets a message, it's going to relay that message to my backend, to my stateless, my other applications. Now, to do this, there's some architectural cleverness that they've done to enable this scenario. And I'm going to try and explain that a little bit. So when your application connects to the API Gateway, it will create a connection, and that's a stateful connection. Like it's a one-to-one connection between the client and Amazon API Gateway. And when a message gets sent down the WebSocket, what happens is API Gateway takes that message and it makes it into a new connection, which it then invokes an API with. So if someone sends 3 messages to down the WebSocket, what's going to happen is API Gateway will convert those 3 messages and then invoke 3. Not separately, but it will invoke the backend 3 times. So whereas a WebSocket is a stateful connection where you have messages being passed back and forth, what happens is API Gateway will take all the messages and then will invoke your backend services. So the backend can be anything. It can be a function. It can be a stateful web application or whatever it's going to be. In my instance, it's a Lambda function, which is a serverless function. And so every time someone sends a message, you have, like in this instance, there's 3 messages being sent to API Gateway. That's going to invoke the Lambda function 3 times, 3 separate times. And I don't know if you know the way that Lambda functions are charged. You pay for how many Lambda, the Lambda functions that are being, the time the Lambda function's running. So if I get a Lambda function invoked 3 times and it takes 10 milliseconds to invoke that function, then I pay 30 milliseconds worth of compute. The other thing that I do is I store some information in a DynamoDB, and I'll explain why a little bit later. The other thing is, though, WebSockets go the one way and the other. So you want the server sometimes have information that it wants to send to the client. So for example, when I switch the slide in my application, that's actually a WebSocket communication, which I want to broadcast to all the connected clients that the slide has changed. So ask different questions. And the way that we do that is every time that someone sends or connects to Amazon API Gateway, it comes across with a identifier for that connection. And if you have that connection ID, then you can use this URL at the bottom here, the connection URL, and it's like a RESTful endpoint that any application can call, and it's HTTPS a random number .execute API what region you're in .amazon.aws.com/n/connections, and then the connection ID that you've got. If you post to that URL, then API Gateway will take that message and it will broadcast it to that particular connection. So the way, if I want to broadcast a message to all of my connected clients, what I do is I get a list of all of the connection IDs, and then I basically loop through all of them. And for every connection, I send a post request to this endpoint, and it will broadcast to each of those people or each of those connections. So you can have this two-way communication. Now, ultimately, it's getting passed down a WebSocket, but my application doesn't know anything about the WebSocket. It's just posting to a URL, a message, and that message is getting somehow routed by API Gateway back to the client. So we have a way of communicating to the endpoint and a way of communicating back, and it means that we can start creating real-time applications. The connection URL has a few capabilities. You can post to it, which is sending a message. You can also get the connection ID, and what we'll do if you do send a GET request is you get the latest status of that particular connection, and you can delete it to disconnect the client as well. So if I want to create an API, I go over to the console, I just click on create an API, ignore that, and I choose WebSocket. Create a fancy API. I have this thing called the route selection expression. So on the request, which is coming in, on the body of that request, there's going to be a message, and that's going to be used to route my messages. Just got to put the thing as request. Create the API. And now we have a couple of different routes. We have a connect route, and a disconnect route, and a default route. So what I say on connection of a Lambda function, I'm going to route it to a Lambda function that I have called onConnect. On disconnect, I'm going to route it to a Lambda function. It doesn't have to be a Lambda function. It could be a REST endpoint. It could be a .NET application, anything. But this Lambda function is going to handle that request coming in. And then I've got one called send message, and that goes and forwards onto a Lambda function too. So now I've got an API. I deploy that API. Pretend that this application is important, so put it over into prod or production. Deploy the application. And then I've got this WebSocket URL. And this is the WebSocket that I will call, and that's the connection URL, which I can call from my application to communicate with any of the connections that I have. So the WebSocket URL is important, and that's going to be used to send. I apologize again. I've not changed this slide. I should say hello NorvDev, but this last time I used this was at Chester Dev, so I apologize. I shouldn't send it. If I was wanting to send a message to someone in an application, I could craft my message like this, and it says message, send message, and data is hello Chester Devs. Now the message portion of that JSON payload is what's going to route it to the correct Lambda function. So in this instance, this particular piece of data will be routed by the API gateway to the send message function. And then there's some data which goes along with that. But it could say on connect, on disconnect, send message, or any other thing or feature in my API. So I have this sort of architecture now, and I know it's complex to think about, but let me try and talk it through, and hopefully you'll understand a little bit about it. We've got an API gateway, we've got Lambda on connect, we've got Lambda send message, and we've got Lambda on disconnect. So the way that works, on connect, what it does is it gets the connection ID and it stores it in DynamoDB, which is like a NoSQL database. So everyone which connects to my application will get a connection ID. I'm going to have a list of those in DynamoDB. If someone wants to send a message, they say they want to send a message, they passed a piece of data across with it. I take the message in my Lambda function, I loop through all of the connections that are in my DynamoDB, and I post to all of them the new message which has come in. And I've got a function which is called onDisconnect, and what that does is it removes the connection ID from the database. So what it means is I can build from that 3 functions and that API, I can build a chat application. So hopefully we go to NorDev chat over here. And you can try, oh, actually, I did change this one to NorDev, I think. Yeah, NorDev.thebeebs. So if you go to NorDev chat and you click on that and then click connect. Did that? Yeah, we go. Sorry, my UI is not particularly great. This is written in Vue.js. Then I can write a message. Hello. Then hopefully that message will come back. Okay. And as you can see, other people have joined this chat as well, and they are randomly typing messages on there. Wave. Sorry, I don't have any short codes or anything. It does have emoji support, but that's probably the most basic chat system you've ever seen. But as you can see, like different people have logged onto this website, and if I went into a different tab over here and connected to it as well, and connected hi from screen 2, send message. And then if I go over to the other thing, then somewhere down there, yeah, it's got it on the bottom, hi from screen 2. Someone's doing select star from where. Sad to thing, there's not really a query language on the back of DynamoDB, and I definitely don't just pass the data over to it. So there's a lot of insecurities in this system, but that is not one of them. So you've got we built a basic chat application. Now the thing you should see is when we connect it up to this site, there's this URL over here. Well, that's the URL which we just created a moment ago. So when I'm crafting a piece of code, and I wonder if I can see it actually. Oh, I tell you what, if I go onto the chat application over on GitHub, you can see like the code in this. It's a really simple Vue.js application. Let me look at the actual JavaScript though. There's a JavaScript file, and we create a WebSocket. It opens, it connects to the socket address. It sends some message over, and then it puts an onMessage handler on it. And every time I send a message, it goes and creates one of those messages with message, send message, and then the data, which is wants to be sent. It sends it to the socket and it pushes it. And then when it receives a message, it takes the message and it pushes it into the application. So it's just send and receiving these messages. So in the background there's a WebSocket which is open, and that's how it's kind of working. Okay, so the functions, the JavaScript, the .NET functions in the background, which are running in these serverless functions, they are this is the send message function in Lambda, and you'll see there's a function handler. If you've not seen a function in a serverless function or a Lambda function, some of this might not make sense. Just think about it as for simplicity's sake, think about it as like a function of .NET. Which every time that Lambda function is invoked, it runs this function, and there's some stuff passed into it. So it's got this API gateway proxy request, so the request that's come in. And what I do is when I send a message, I get the object, the data object, and I basically do a scan request on DynamoDB, which is basically a search for all the connection IDs. And then I'll do a for each across all of the connection IDs, and I post. There's a post to the connection request, which is my API endpoint, my connections API. Now it's wrapped up in this little like helper object, post to connection request. But fundamentally, you could just write this as like a, I could just do this as a HTTP request to that endpoint, and it would post that message to it. So I loop through it all, and I send the message to everyone, which effectively broadcasts it. So I built this, and then it was like, well, I've written this in SignalR and .NET. Problem is with that, I need that scaled backend with the Redis to do scaling of this, and I need EC2 instances to run my .NET application. Now I could have containerized it, made it into containers, and run it in one of our container platforms. That would have been a cheaper way of running this application, especially if I was going to run it on Linux, because it's a .NET. This is .NET 3.1 at the moment, so I could have absolutely run this on Linux. It would have made it cheaper. I could have even run Linux on Elastic Beanstalk, which would have made it cheaper. But I was thinking, wouldn't it be cool just to use Blazor and use the WebAssembly version of Blazor to the front end of my application to all be in Blazor, and then I can not host it, don't need EC2 or anything to host it. I can just host it in storage. So I could just host it in S3. So we have a really nice little feature called Amplify Console. And Amplify Console allows you to host static websites. So it didn't take me very much to take the website, the Blazor application, have a build process, which put my static application onto Amplify Console. And what does is basically it hosts my website. It allows me to put a HTTPS certificate in front of it. It allows me to do the domain management of that static website, and it costs practically nothing to run the application. Like I'm talking, I don't even know how much it costs, less than $1 a month to run my front end of my website. And then my Lambda functions, I only ever pay for them when they're being used. So even if they're not being used and no one's talking in my application or voting in my application, I'm not paying a penny. So my application went from being hundreds and hundreds of pounds a month, albeit I would switch it off and on, to something I can just leave running all the time. And it cost me, I think my bill on that AWS account at the moment is $3 for this month. And I do a lot of other stuff on this account as well. So it makes it very, very inexpensive. So there are two ways you can run Blazor. The one is Blazor WebAssembly. The other one's called Blazor Server. I've not really looked too much into Blazor Server, but to scale it using Blazor Server, you really have to use it's really difficult to scale because it basically what happens is that every invocation and redraw of the UI is passed to the server redraws it and then passes it back over a WebSocket, weirdly enough. And then you can have this benefit of in-client Blazor. I don't really like Blazor Server, but Blazor WebAssembly, what it lets you do is write all of your application in C# and then host it all in the browser. And it's using under the hood this thing called WebAssembly, which is it's sort of compiling .NET so that you can write C# in the browser. And as a regular .NET developer, I can just write all of my client-side logic in C#, but it's actually now I don't need a powerful server to run it because it's all going to be running in the browser. So I just need static hosting to run it. So Blazor WebAssembly, in my opinion, scales really well. Super cheap to run. That's why I chose it. So I started looking at the application, started converting it over. So at the moment, the UI is not the same, but it's this. It's basically I have a questions page and a voting page. So this is the questions page. And what I did to create it is I went over to the Blazor website and I said, get started. You have to do a few things. You have to do a .NET new Blazor WASM site, which creates you a base project. That creates this fundamental sort of back-end, front-end sort of application. What I did is I went and changed I kept it quite straightforward. My questions for my site are actually just hard-coded into this questions.json file. I then have this index, questions, and vote page. The index page just says, hello world, welcome to my new app. The questions.razor, that has a little bit more to it. What it does is on initialization. So it's got a life cycle, a bit like a .NET application, Blazor. So I have this protected overrides async task on initialized, and it's basically as the page loads, it's going to run this piece of code. And what I do is I basically do a get JSON asynchronously from a local file. This could obviously be from a web service or from a data. I could even write some code in here to get it from a database. But I'm just getting it from the local questions.json file. I load that information into this object called questions. This questions is a hard-coded class. It has an ID, a title, an answer 1, answer 2, a picture 1, a picture 2. And I end up with a list of that. And then my Razor code, like the logic, display logic, is looks a bit like this. And it's, so if there's no questions yet loaded, and once the questions have loaded, and once the files come back, and it's then going to go and create a table, a title, answer 1, answer 2, answer 1 count, and answer 2 count. And then I've got a for each loop, which loops through the actual questions, and will print all of the questions out. So it's just like a table with all of the questions that could be asked. And then I've got 2 buttons. These are HTML buttons in my page, but you'll notice there's that on click. In Blazor, what that means is that's routing it to a .NET function. And you'll see that I say on click, previous question, on click, next question. So I've implemented the handlers of those in C#. So I've got next question. What it does is it says the current count is, if it's next question, it increases the current count. And if it's the previous question, it negates the current count. So I'm either adding to the current count or negating to the current count. And there's just a check to say that I'm not going past the length or going below 0. And you'll see that in my for loop of the questions, I've got this if statement. It says if the I equals the current count, then it'll display the question. So what I'm doing is I'm looping through all of my questions. And if one of the questions has the ID of the current question, then it will be displayed. Otherwise, it won't. And what that means is that I'm able to then create that creates the logic so that when I go to questions, it loads up the questions and it only shows one question. And when I click next, it shows the next question, and previous and next, it shows the next question. What it's doing is it's redrawing the screen all in .NET. The logic, I'm not using JavaScript anywhere there. It's all just .NET. And that's one of the cool things about Blazor. I'm able to do it just all in .NET. You'll notice at the top underneath questions, it says it's connected to WebSocket, because I've implemented a WebSocket there as well, which I'll talk a little bit about. Now, the voting screen is almost exactly the same. The only difference is that it has the ability to vote on different questions. So it prints out all of the current questions and shows the current question, but then allows the user to vote as well. So same sort of principle, but they can vote for tabs or they can vote for spaces, depending on what question they are in. Now, when we start up the application, when I first came to do this at the start of the year, last year, 2020, you had to do this using JavaScript interop, which is a real pain because Blazor didn't support WebSockets. It supported HTTP, but it didn't support WebSockets. So that you'd have to basically write most of your WebSocket handling code in JavaScript and then create an interrupt between that and C#. So my C# started getting sort of muddled with this. You'll see it on line 56, await JS runtime invoke async. And it's actually invoking some JavaScript on my page from .NET. I didn't really like this very much, but it worked. And then I was at NDC presenting this topic, and Steve Sanderson, who's one of the brains behind Blazor, said that they just checked in like the capability to intercept WebSockets. And so we now have, we don't have to do all of this. This is the helper that I built in JavaScript. And this is the way that people would vote on the different answers. And it would be invoking or sending messages to the WebSocket. But it became really, really complicated. I ended up adding another Lambda function in my application called vote. And it does a similar thing to send message, but it votes rather than sends a message. So it's strict that it only allows a 1 or a 2 to be passed around for a different question ID. And I construct it slightly differently. So instead of just having a data object, I have a question ID and an answer ID. And I've got this message called vote. So it gets routed to another Lambda function. The Lambda function operates slightly differently to what send message does, but ultimately it basically stores the votes which people are voting in my application in a table for me. This is the vote function. I won't go into that particularly because I've run out of time. But yeah, this really annoyed me, this whole sort of this on socket, on message, and then having this invoking methods. And you basically were, it's helpful that Blazor supports this capability to speak to JavaScript from .NET. But really, I want to just write sockets in .NET. But anyway, I got it working with JavaScript and .NET and making it invocable. So you'll see is I'm pressing the voting tabs in my application. You see Chrome DevTools there showing that I am actually sending my information over to a network and to a WebSocket endpoint, and that's sort of getting captured there by the tools. So if I have two browsers open and one's on questions and one's on vote, I can vote, and you'll see that it's being reflected on the question screen there. Now, the cool thing is that the Blazor application, I can host that static hosting, and the functions are in Lambda. It's significantly less expensive to run this application. It's incredibly scalable. I can have thousands and thousands of people using this simultaneously. It won't crash out. I don't have to worry about expanding the capability of, you know, how many servers I've got in the back end to service this. I could as easily use this with 10 people as I could thousands and thousands of people. And the only difference is I'll pay more the more it's used, because I'm paying per millisecond. Lambda is charged per millisecond of compute. So what Steve explained to me is that they've added this. I wanted to use WebSockets like system.net.websockets in my Blazor application. But to do that in Blazor, they have to intercept that connection. They've actually done that now, so that I can just basically go in my vote screen. I can have a thing which systems.net WebSocket. So I could just open a WebSocket as if it was just .NET, plain old .NET. So that then inside of my on initialized, I've got my cancellation token, because you're dealing with WebSockets and say where .NET is actually using them. And I've got this WebSocket connect async. I pass the URL over to it. I've then got this receive loop, which basically is a loop which is constantly looping to receive messages as they come in. But then all of my code is now in .NET, and I'm doing .NET in the browser on the client, dealing with WebSockets using systems.net.websockets as you would from a .NET console application, rather than having to interrupt between this and JavaScript. If I look in my browser, when I'm doing any interrupt with WebSockets, I will see it in the browser as if it's being sent by JavaScript. It looks just like regular regular WebSockets going over the network. But it's all built using C# instead of JavaScript. So now I have built the basics of my application. It's using these functions, but now I've got some stuff to do. I need to improve the UI. I've actually missed off the I of UI there in these to-dos. These are all issues, by the way, on my project. I need to move the preview bits over to .NET 5, because subsequently they've actually moved it over. They now support .NET 5 in Blazor, and I think these bits were built on 3.1. The Lambda functions that I've got, they're currently ASP.NET 3.1. Sorry, .NET 3.1. I need to move them to .NET 5. I'm going to use containers on Lambda. Like, there's a new capability in Lambda to the way the Lambda usually works at the moment is that I would build these files, create it into a project. It creates it into a zip file. Then I post that to Lambda. Then that's how the function's created. Now Lambda you can send a container to Lambda functions. And that container, if it's crafted in a specific way, that can handle the logic. So I'm going to do that. I need a CI/CD pipeline so that I don't have to do some of this build manually, which is what I'm doing at the moment. And I need to add an authentication system, because at the moment it's pretty open that you could, if you knew the right URLs, you could post messages and control the slide deck. And I don't really want that to be the case. So I need to add some UI and some UIs for authorization, so that at least the person which is managing the voting system is authenticated. If you're interested at all, the code's on github.com/thebeebs/Blazor voting demo. And if you want to help me, then that would be great. My name is Martin Beebe. I'm at the Beebs on Twitter. And if you haven't, I know, sorry that I've overrun a little bit there. But if you've got any questions, then please put them to me.
Thanks, Martin. That was pretty interesting, particularly the API gateway stuff. I didn't know about the WebSocket stuff and the Lambdas and converting WebSockets to HTTP. That's pretty cool. Question-wise, we had a question in from John A about what the code, application code in the browser debugger looks like, being that it's .NET source code. I'm assuming you could possibly look at demo.
Yeah, well, so actually, I don't know if I've got anything live at the moment, but the difference you'll see in the dev tools for a Blazor application, let me just see if I've got anything. I need to log into a different AWS account. This one. This is Amplify, by the way. This is the way that I manage my my applications for this stuff. It's a, let me just see, all apps. I don't know if I've actually got a Blazor application hosted on here yet in this account, or is it my other account? No. So the difference between what you'll see in a Blazor application is fundamentally it'll look exactly the same, but you'll see on the networking tab that it will be downloading DLLs. So you'll see the DLLs which are actually downloaded inside of the networking tab. And so that means that it makes it a little bit, what's the word? It's interesting because it can add problems like, because you're downloading DLLs and because we're not crafting DLLs to be super small, there is often with Blazor applications this little jerk of like, it takes a little bit of time to kick in and to get because all the DLLs have to download before the application can start. So you have this sort of latency before the application starts. But then from that point on, everything roughly looks the same. I'm sorry, I don't have the demo in my account at the moment, but I'll publish that later so that you can have a look and go to it. So I'll publish it on serverless.thebeebs.net, and you'll be able to see the application running. It looks identical to sort of regular JavaScript application. The only way that you can sort of tell that it's a Blazor application is that you have these DLLs running in the background. Yeah, is that Blazor? That might be Blazor.
Gotta say, I saw the DLLs downloading in one of the demos and was just a bit like, ooh. It was a bit of a weird moment where it's just like, hang on a minute, what is that? Network tools with DLL files in it?
What are you doing to me, Martin?
It is strange, like the way that Blazor is working. So what it's effectively doing is that, in the browser, effectively, we're running that .NET application. So it needs to have all the DLLs which are running it. It's not just running JavaScript. Like this isn't an interpreted language. It's not converting your .NET into JavaScript to then run it. It's actually converting it into effectively into sort of machine code. So but it does require all the .NET parts, including DLLs and stuff, which does make it really weird dealing with.
I think I've read recently that they've been making strides to reduce a lot of the DLLs that you have to ship down to the web. It's been getting a lot smaller.
Yeah, I was ill over Christmas, so I gave this a really good looking at this project about 3 months ago, and then I've not done much work on it since. But yeah, it's always improving, because I only released the release version of it late last year. So with .NET 5, there was lots of new capabilities, and they were trying to improve some of the stuff around lags and startup lags and things like that. But I think and there's definitely like cases where not every .NET DLL is going to work. We've recently, very, very recently, changed the AWS SDK so that it can work inside of Blazor. It's still experimental. We're not completely published. We're not completely okay yet with it working. But you can use, there is a version of the AWS SDK that you can use within Blazor applications as well. So yeah, there's lots. Blazor's like, it's for me, it's not, I don't know how I feel about Blazor. I like it. I find it interesting that I can write .NET, but I can also write JavaScript. So I'm sort of thinking maybe I'm adding complexity to my life. I could just write this in Vue.js. but it is nice when you see like you're actually writing this stuff, using WebSockets as if they're .NET WebSockets. That's cool. It's really cool. And it means that I don't have to learn some of the idiosyncrasies of JavaScript, maybe. Sadly, I'm already at that part of my life where I've already spent a good 10 years learning the idiosyncrasies of JavaScript. But for people which are already .NET devs, which have never looked at JavaScript, like Blazor's brilliant.
Martin,
never looked at JavaScript. Wow.
Oh, go. Sorry, Alex.
No, go. No, I was
just saying. So, you watch this video and you've got a sort of an entry level 101 type introduction into how this works and how you can use Blazor and Lambda functions and everything else. Where do you go for that sort of? What would be a next best step after sort of watching this and following some of your guys, looking at your code? Where do you go to next? How do you start to get more information about the specifics of what you're doing?
Well, absolutely. If you want the specifics, then just go to the GitHub URL. So that's like that. That's where it's based. There's not many people which are doing. This kind of thing directly. In the trying to use WebSockets inside of Blazor applications. Really, there was. We have an event at AWS called reInvent. There was a session there. I'm just going to have to try and find it though at the moment. What will I have to search for? It's in my Slack, but I daren't open my Slack.
No, don't. Life's too short for that.
I'll tell you what.
Yeah, maybe you could include a link at the end of it on the YouTube.
I'll tell you what I'll do. I'll tell you what I'll do instead. If you follow me on Twitter, which is twitter.com/thebeebs. Why can't I spell my own name? The Beebs on Twitter. Then in a few moments, I will. I'm not logged into my account. I will post the links to like further reading. If you go to my website as well, thebeebs.net, I think I'll probably have written this up somewhere on there.
Okay, cool. Thanks.
But definitely look at my Twitter, and I'll post the links to some of sort of next stages if you want to learn a little bit more about it.
Yeah.
Cool.
Jono is asking for some further interest, potentially looking to integrate Cognito into this application. I've really struggled with .NET and serverless and Cognito. Feels like a third world citizen. I'm assuming Cognito feels like the third world citizen.
So there's some complications, right? So Cognito is like our serverless authorization system. So you can use it to do like. It's all part, it's basically a standalone service, and you can very easily from a .NET application use Cognito. In Blazor, it's harder because Blazor, as I said before, Blazor doesn't have support for the AWS SDK. So all of the helper functionality that we have in the SDK for things like Cognito is not there. So you have to use Cognito at the moment in Blazor, with a little bit, you have to basically use the JavaScript implementation and then do some interop, and it can be really painful. Obviously, we're looking at what tooling and support we can provide at AWS to make it easier to work with Blazor. We've obviously already got our full fat SDK converted into a form that it can be used in Blazor, but we're still thinking about ways that we can make it a bit easier to do that. And that's exactly one of the reasons I've held off on implementing it in the application, is purely because like, I don't really want to. I could maybe implement Cognito as it stands, but I know that I would be using JavaScript. I'd probably be using JavaScript and using that interrupt capability with Blazor. Because the cool thing about Blazor is, yes, you do most of it in .NET, but there is this ability to sort of drop into JavaScript if you need to, and interact with JavaScript. And so sometimes that's the case. And most of the implementations I've seen of Cognito in Blazor, they do that. They use the JavaScript implementation, and they make nicer, easier ways of dealing with it in .NET. But it's still a little bit icky. With the SDK support, I should imagine, I've not tried it, but you should be able to use Cognito in a much more normal way. But that's still the next piece of my journey. Really, is to figure out how to do the auth on this. There's lots of ways I could do it, but I want to try and create a clean way, which is nice, easy to use, repeatable. And the cool thing about Cognito, and the whole reason people use Cognito in serverless applications, is because, you know, it's a few lines of code and you've got the auth system. So it will do the login, log out. It will do verification by SMS, two-factor authentication, those sorts of things that you get from a login system. And you don't really want to spend too much time. So I'm even thinking about maybe writing a plugin for Blazor. I've not written one yet, and it feels like that's a place that you could quite easily write a control that we use in Blazor. I don't know what the Blazor terminology for controls is, but write a control. You could quite easily write a control for it to sort of support all the authentication thing. In Amplify, which is a JavaScript framework we have at AWS, they have a thing called hosted UI, which is like a really nice hosted UI version of Cognito. So you're able to do like sign in, sign out, but then also log in with Facebook, log in with Google, and all of those, you know, the OAuth stuff. It would be nice to have that sort of capability in Blazor. We don't have it at the moment, but that's what I'm hoping we can try and build, maybe open source as a control.
Early days, still early days.
Yeah, I mean, Blazor's not that young. It's been kicking about for a while, but I think it's only recently sort of started to get really serious, because it used to, I actually ran an event called JavaScript Days in London, I think in 2016, and a gentleman called Steve Sanderson presented there, and he spoke on stage about converting. He basically took a C++ application, or I think it was, what was it? It was a database. It was a local C database implementation, and he ran it in the browser, and he basically mused on stage and said, like, you could probably do this with a managed language, but there'd be a whole lot of complexity in that. And Steve then went on and did just that. So he went on to go and make it into a managed that managed language with built in the same way that he did in the browser, and then that's became Blazor. So it used to be just like a pet project of Steve's, and then he worked at Microsoft already, but then he joined the ASP.NET team, and then they furthered it and converted it into this whole Blazor project. And now there's quite a lot of, it's quite serious. Before, I don't think people were sure if it would be possible to really do this, and now it feels like that, you know, people are genuinely building real things now. So it's still very much in its infancy, but it's not brand new. It's still quite a few years old, the base concept, but now it's more productionized. And obviously the first release of it was last year. I think as we start to see more and more releases, it will start becoming more and more useful. There'll be more support for it. There's already companies out there building components for it to make, you know, data grids and those sorts of things for Blazor. I think you'll start seeing more and more of that sort of stuff, and companies like AWS providing direct support or SDKs or whatever we need to provide to make building Blazor applications better and easier. And if you're out there thinking, I've got a great idea that's something AWS could build to make it easier to work with Blazor, do tell us, because it's that sort of feedback that we can then sort of pitch as an idea internally to sort of maybe go build that thing. So if there are things that, you know, you want to see inside of Blazor which are hard to do today, that we maybe offer, you know, I don't know what it would be, but integration with our AI services, integration with our database services, whatever that might be, let us know, and we can see, you know, we can see if we can do anything. No promises, but like, it's not me, it's certainly not even my team which do that. It's another team at AWS. I can always let them know that those are requested features from the community.
It seems like authentication is a particularly troubling subject. Kafina over on YouTube has been saying that also having trouble integrating Cognito. But
well, that could be
that nice is the statement.
Yeah, no. And I completely, as I say, I get it, because it's not, to be honest, it's not been developed for Blazor. So, you know, I think that's, maybe it's going to be I've already felt a little bit of the pain because I tried to do it and it took me, you know, I'd sort of spun about 4 hours worth of work trying to get it working, and then was like, actually, I'll come back to this later, and have just not got back to it yet. So maybe that can be one of my first projects this year, to try and get Cognito working on it and see if you
heard it here first. You're on the line now.
I didn't say I was good.
Repo by end of March.
I'll try and build something for my project, so it's like I can see what the state of play is, but then maybe use that to petition internally to try and build something which is a little bit more nice. And maybe that will be just the AWS SDK working in Blazor and those parts working. I don't really know. But we'll see.
Follow the Twitters. I've shared the links to Twitter and the GitHubs in the chats everywhere. So yeah,
cool.
Follow along. If there are any further questions on the YouTube before we let you go for the evening. We've got a few moments. There's 43 people watching in behind. So yeah, I guess tweet Martin any questions. I'm sure he'll help. But yeah, thanks for joining us this evening, YouTubers. And we'll see you March the 18th, if not before, at the Virtual Social Club. So bye-bye, YouTubers.
Thanks, Martin. Thanks, Alex. Thanks all.